Okay, hello everyone. Good morning to all of you. In our last class, we have been discussed in detail about electric field intensity. One second. Electric field intensity due to a uniformly charged circular ring at any point P on the axial on its axis. Then what will be the electric field intensity? That we have been discussed in our last class in detail, and we found this much. And also two cases we have been discussed, that if the point will be at center, what will the value, and if the point will be at larger distance, what will the value, that we have been discussed. In our today class, we are going to discuss electric field intensity due to electric dipole. First we have to discuss in this class on axial line, then we are going to go for the equatorial line. So for that we have to consider a electric dipole, that two opposite charges are separated by a distance, suppose 2a, and this is the middle point of this dipole. So obviously this distance B to O will be A and O to A will be A. Now we are going to consider axial line, that means along x-axis, positive x-axis. Any arbitrary point P, suppose here that point P will be at a distance r from the center O of this dipole. Now due to positive charge, this positive charge, what will be the electric field intensity direction? That means if we are going to place a unit positive charge here, then this positive charge will be repelled along this direction. That means due to positive charge plus q, which is at A, electric field intensity direction will be this direction. Okay, that means suppose we are going to consider E1 is the electric field due to this positive charge, then what will be its value? Value will be 1 by 4 pi epsilon 0, and the distance means this distance from A to P, distance square, AP square. Here if O to P is the distance is your R, so obviously A to P will be R minus A. So E1 value will be 1 by 4 pi epsilon 0 q by R minus A whole square I cap, because I cap means along positive x-axis direction, or we can write AP direction. So either you can write along AP direction or I cap, no problem. Okay, now if we are going to consider this negative charge, then for this negative charge, if I am going to put a unit positive charge at P, then this unit positive charge will be attract towards this direction, that means along negative x-axis direction, that means I cap direction minus I cap direction, or we can write A B direction or PB direction. Okay, so electric field intensity due to negative charge which is placed at B will be along this direction, PB direction, or along minus I cap direction. Let us consider that is your E2. The value of E2 will be 1 by 4 pi epsilon 0. Q is the magnitude of this charge, BP square, that means B to P distance square. So if O to P is your R and B to O is your A, so obviously this BP distance will be how much? R plus A square. So here minus I cap indicates that the direction of electric field intensity due to negative charge will be along this direction, along negative x-axis direction. So here also I suggest that either you have to write minus I cap or along PB direction. The resultant electric field intensity at point will be how much? That we have to add the electric field intensity due to this charge at point P due to negative charge at this point P. That means E1 plus E2. Okay, so E1 value here I substituted and E2 value here I substituted. Okay, Now we are going to calculate these two values. Just simplify e1 plus e2, this much whatever I written in last slide, and here I written that along AP direction. Why along AP direction? Here you can see that if we are going to consider the magnitude of E1 and the magnitude of E2, the magnitude of E1 is greater than that of the magnitude of E2. Why? The denominator of this E1 is less than this denominator of E2. So here R minus A is less than that of the R plus A. So obviously magnitude of E1 is greater than that of the magnitude of E2. So hence the net electric field intensity will be along AP direction. That means along this direction. So here in the figure itself I drawn the same, that this vector E1 is the larger length and E2 is your smaller length. So whenever you are going to write your note, so you have to care about that. Okay. Now we are going to simplify this two addition, that here q by 4 pi epsilon 0 taken outside, 1 by r minus a square minus 1 by r plus a square I cap. So you just simplify, it is very simple simplification. So we can found 4ar by r square minus a square whole square. Okay, so here you can see this value will be r minus a square into r plus a square will be r square minus a square whole square. Okay, here carefully you have to watch that here 4ar can be written as 4ar and this q. Okay, so we can write that 4, mistakenly I written this one, this will be 1. Okay, you just remove it, this is 1 by, okay, this is 1 by 1 by, okay. So here q is there, so we can write this 2ar q can be written as 2 into 2aq into r, okay, 2aq into r by r square minus a square whole square I cap is there. Okay, and we know that 2aq, that 2a is the separation between the two charges, separation between the two charges multiplied with q, that means dipole moment magnitude. And if we are going to consider its direction, direction is along positive x-axis direction. So here this value 2aq will be written, 2aq and I cap will be p vector. Okay, so here I mistakenly written q, I told that you have to write here 1 1. So finally we found that this one is the answer, that 1 by 4 pi epsilon 0 2 p r by r square minus a square whole square along AP direction, electric field intensity, net electric field intensity at point P. Now if we are going to consider a and r, so here a is very small as compared with r, that means r, this distance is large as compared with this a. So obviously a square will be very small as compared to r square, so a square will be neglected in this term, and finally we can found E will be equal to 1 by, this will be 1 by 2p by this one, here you can see r square minus a square whole square, and this r is there. Here you can see this will be 1. Okay, so this value will be r to the power 4 and this r will be cancelled out, r cube finally we have to find, we can found finally r cube. So here we found electric field intensity at point P due to this electric dipole will be this much. Okay, so in our next class, equatorial line. Okay, so thank you so much for joining this class.